what's a monomial? A monomial is a number. So it could be any number, any, what do you call it, natural number. A variable, which could be a letter, a number that we don't know. Or a product. A product is what you get when you multiply numbers together of a number and one or more variables. This is an example of monomials. Notice 25x, 40x. X plus 4 is not a monomial. Monomial means, mono means one. One. It stands alone as one term. This is one term, this is one term, and this is one term. But this is not standing alone. You see they're being added. There's a computation happening there. Okay? And then when we have 40x plus 120, again, this is not a term. So they're not monomial. Monomial, they have to be already as one expression, such as coefficients and so on, and like terms. Okay, to factor a number means to write it as a product of its factors. A monomial can be factored using the same method you would use to factor a number. Okay, when we're looking for the greatest common factor. The greatest common factor, or GCF, of two monomials is the greatest monomial that is a factor of both. And that's what we've been searching so far. This lesson will remind you of how we used to do prime factorization in 5th grade. Okay? Well, look here. We have 4x and 12x. Okay? 4x and 12x. So we know that for 4x we have 2 times 2 times x is 4x. And for 12x we have 2 times 2 times 3. Remember, these are the prime numbers, right? The prime numbers of 12 with prime factorization. And we collect the ones that are common, and that's going to be our greatest common factor. So this gives us 4x, and that's the greatest common factor, as you can see there. And now we have 18a and 28b. There's no b here in the 18a, but we go ahead and let's do the prime factorization of 2 times 3 times 3 times a, and over here for 20 it's going to be 2 times 2 times 5 times a times b. Right? You just do the prime factorization. If you don't remember how to do the prime factorization, simply make a prime tree. Remember the prime tree? Where we write the number on the top, and then we say 2 times 10, and then 2 times 5, and there's our prime factorization for 20. You can see here that it's 2 times 2 times 5, right? There it is. 2 times 2 times 5. And then AB. Right? And we collect the ones that I have in common, so the greatest common factor is going to be just simply 2A. And the same thing applies for 12 CD and 36 CD. Remember, make a prime tree. If you don't know how to come up with all these prime numbers, make your prime trees. Write 36 and always keep the prime numbers to the left. Okay? So I know that my first prime number, this number is divisible by 2, so it's 2 times 12. And I know again it's 2 times 6, and I know again it's 2 times 3. And there's my prime numbers. Right? There you have it. 2 times 2 times 3 times... Oh, wait a minute. I made a mistake. I said 2 times 12. It's 3 times 12. 3 times 12. Sorry, 3 times 12 is 36. There we go. It's 36. So it's 3, 3, 2, 2, and you see 2, 2, 3, 3. Okay. And then we find what's in common between the two of them. So it's going to be 4, 12 CD. 12 CD. Okay, if you're feeling confident, you're ready to try page 416 on your own. So pause the video, try these 3, and then watch how I do it. Okay, I hope you paused the video. I hope you're one of those people that said, yeah, I know how to do this. I'm confident. So we have 12. And for 12, I know I have 2 and 6, and 2 and 3. So there's my prime numbers. Okay, and for 28, I have 2 and 14. Yeah. And again, 2 and 7. And there's my prime numbers. Okay, 2 and 7. So I know that I have 2's in common, and that's it. So I have 4. 2 times 2 is 4. And the C is not in common because 12 doesn't have a C. So it's just simply 4. So the greatest common factor for this one, GCF, equals 4. You get it? Okay, let's try B. So I write 25. 25 is not divisible by 2. It's not divisible by 3, but it is divisible by 5. And that's all I have, 5 times 5. And for 15, it's divisible by 3 times 5. And that's it. I got my prime numbers. The only ones I have in common are the 5s. So, and I also have the x's, as you can see there. So 5x is going to be my greatest common factor. So GCF equals 5x. x. And again, 42, I have 2 and 21, 3 and 7. And that's it. Those are my prime numbers. 14, I have 2 and 7, right? 2 and 7. So I have 2 and a 7, and I have a 2 and a 7. So all I have is just 14 so far, and they both have m and n, m and n. So m, n, 14, m, n. And there you have it. Copy it down, please. I hope you're getting this. You can use the distributive property and the work backward, and then work backwards, okay? Strategy to express a linear expression as a product of its factors. A linear expression is in factored form when it is expressed as the product of its factor. What do they mean by that? There it is. Okay, we are writing it in their factor form, right there, factored form. Okay, and then here we have it already factored, and this is when we use the distributive property. I will use distributive property here to get this again. For the sake of making the video shorter, please pause the video and take a look at example 4. Follow it carefully. Make sure that you read what they have done in each step. Okay, so you should be able to do it. The idea is to get you to be an independent learner and learn how to follow these examples. Do the same with 5, please. Pay attention to the fact that 12x plus 7 cannot be factored because there is no common factor. Okay, I hope you did look at example 4 and 5 carefully and that you're feeling confident in how to do this. If you are, please pause the video and try it. Otherwise, watch how I do it. I'm going to look for the greatest common factor for 4 and 28, and I know that 4 is a factor of 28, 4 times 7, right? So I can put my 4 on the outside, x inside, minus 7, and that'll give you that. Okay, for 3 and 33, I know that my for 3 and 33, my greatest common factor is going to be 3, right? Because 3 times x is 3x, and 3 times 11 is going to give me 33. But my y is not a common factor, and nor is my x. They're not common. So I just simply take my 3 out of the mix. I leave my x in there, plus 11, because I know 3 times 11 is 33, y. And there you go. 4 and 35, this is divisible by 2, but this one's not. They're both not divisible by 3, and this one's divisible by 5, but this one's not. So there's actually not a common factor. This cannot be factored. So it cannot be factored. Again, for the sake of saving time, please take a look at example 6, and you can see how we've done. They're putting everything together now, but they're just relating it to a real-world example. And as I mentioned, you get a break today when it comes to the independent practice. You do not have to do it. You will do it in class. Okay, we'll do it together in class, but here it is. All right, everyone. See you next class.